ATP travels down a motor neuron towards a muscle. When the ATP arrives at the synaptic knob of the neuron, it allows voltage-gated calcium channels to open and attach to the synaptic vesicles containing acetylcholine. The attachment of calcium ions causes vesicles to undergo exocytosis, which then leave the axon terminal. Acetylcholine enters into a synaptic cleft and drifts and attaches to the receptor proteins on the sarcolemma. The receptor proteins then open up and become permeable to sodium ions, which rush in by diffusion, causing inside depolarization down to the T-tubule.
Sodium travels down the T-tubule where it comes near the sarcoplasmic reticulum, bumping out the calcium, allowing calcium ions to move to the sarcomere.
Calcium moves to sarcomere, changing the shape of the troponin tropomyosin, exposing binding sites on the actin filaments. The myosin heads then bind to those bonding sites. ATP then comes from the mitochondria and binds with the myosin head, causing it to detach from the actin. After this, the myosin head releases the now called ADP. Calcium is sent back to the sarcoplasmic reticulum by ATP.
Today we're here to talk about what happens to your body after you die. The lack of ATP production after death does not allow the cross bridge, which is right here, to detach, also not allowing the calcium to return to the sarcoplasmic reticulum.
Myosin head to the bonding site, then comes from the mitochondria.
Containing acetylcholine, attachment of calcium ions. Oh my gosh.